Associate Director, Seedec, Kolkata. Engineer Ramchandra Chakraborty, Member, West Bengal State Center and Convener, Electronics and Telecommunication Engineering Division. Mr. Chanchal Chakraborty, Joint Convener, Electronics and Telecommunication Engineering Division. Professor Nitosh Kumar Brahmo, Honorary Secretary, West Bengal State Center. My colleague in the Council, Engineer Santosh Mutha, Council Member, corporate members, students, guests, ladies and gentlemen. It's my great pleasure and honor to welcome you all at the webinar on Convergence of IoT and AI, organized by Electronics and Telecommunication Engineering Division of West Bengal State Center of Institution of Engineers, India. I'm proud to say that the Institution of Engineers, India is a statutory body to promote and advance the engineering and technology. It was established in the year 1920 and incorporated by Royal Charter in the year 1935. It is the largest multidisciplinary professional body of engineers encompassing 15 engineering disciplines with a membership of more than 8 lakh. It is serving the nation relentlessly for more than a century. The IEI has its headquarters located in Kolkata with national presence through more than 100 centers, 6 overseas chapters, and 9 forums. The latest forum of IEI is Disaster Management Forum, which is located at Dehradun. The Institution of Engineers India issues Chartered Engineer Certificate to its corporate members, by virtue of which one can empaneled in the original site of High Courts, Central Excise and Customs, and other similar government organizations. You will be proud to know that by virtue of being a full member of the International Professional Engineers Agreement since 2009, the IEI represents India and has been empowered to establish and maintain the India section of the International Professional Engineers Register. We have a number of INPE as well as professional engineers under our role. In order to promote the research and development work in the field of electronics and telecommunication engineering, the institution publishes Journal of the Institution of Engineers, Series B, journal in collaboration with Messrs. Springer, which is an internationally peer-reviewed journal. The journal is published 4 times in a year and serves the national and international engineering community through dissemination of scientific knowledge on practical engineering and design methodologies pertaining to electronics and telecommunication engineering. In tune with the objective of the Division Board, the Electronics and Telecommunication Engineering Divisional Committee of West Bengal State Center has organized this evening program on Convergence of IoT and AI. I wish the webinar a great success. Welcoming you all once again. Thank you and have a wonderful evening. Thank you.
And thank you, Mr. Chairman, sir, for your welcome address. I could not see Mr. Kamal there. He has not joined yet. Okay. So next, we have Mr. Swapan Bhumik, Chairman, Committee for Advancement of Technology and Engineering.
No, he is not available.
He is not.
No, actually, Mr. Swapan Bhumik is not the chairman of CARTE right now.
Okay.
The chairman has already been changed.
Okay, okay. Then you have to update this. Okay.
Oh, please.
And Dr. Sengupta, may I request you to say a few words?
No, sir, I kindly request our president.
Okay, then. Okay. Then I'll move. May I request our president, Dr. Thackeray, to address the gathering?
Good evening, all. Eminent panelist, Dr. Nabarum Bhattacharya ji, Senior Director and Center Head, Seedec, Kolkata. Mr. Akulesh Ghosh, Associate Director, Seedec, Kolkata. Moderator, Mr. Ramchandra Chakraborty, Managing Director, PSI Metals India Private Limited. Vice President and my younger brother, Sandeep Kumar Dev. Professor Nitesh Kumar Brahma, corporate members, my council colleagues, and dear attendees. This is a great opportunity for all of us to be a part of this technical webinar on convergence of IoT and AI, being organized by West Bengal State Center under the aegis of Electronics and Telecommunication Engineering Division. You are aware that the effort of the institution has always been to keep its members informed and abreast about the latest engineering and technological developments occurring in national and international arena through conduct of technical events involving eminent professionals and practitioners. Over its last 100 years of existence, the institution has provided valuable suggestions and policy inputs to the policymakers contributing to national growth. With strictly imposed restrictions, technical webinars conducted by the IEI on topical issues have provided a virtual knowledge sharing platform for our members and many other professionals attached to the trade. The Institution of Engineers India has conducted more than 70 technical webinars for the last 1.5 years with comprehensive coverage of various engineering topics, which have witnessed enthusiastic participation from a wide range of professionals. Today's webinar on the theme Convergence of IoT and AI is continuation of the series of technical webinars being organized by IEI. As the critical situation arising out of the pandemic due to COVID-19 has restricted our movements and intervening with the people, IEI has ventured into utilizing the online platform to organize technical activities for the benefit of engineering fraternity. I am very happy that the topic of which is very relevant in the present day context, where we are moving towards Industry 5.0, smart city concept, building 5G network, and talking about big data, has been selected for the webinar. While IoT helps in the communication and interaction of large volumes of data without human interference, artificial intelligence enables decision-making by processing a large amount of complex, organized, and unorganized data obtained through a network of technology and sensors. I believe this platform provided by the IEA is a great opportunity to know more about this interesting topic. I hope the discussion during today's session will highlight various aspects of IoT and AI. Wishing the event a grand success. Thank you. Jai Hind.
Thank you, Dr. Thakre, for your address and for your time. We are really very happy to have you with us this evening. May I request now Mr. Santosh Kumar Mutha to say a few words this evening?
Mr. Santosh, you please unmute yourself first.
Sir, with your permission, if you permit me, that before I speak, can we have a word with Mr. Bhattacharya or Mr. Ghosh, so that then we can have an interesting session with them regarding this particular topic?
Okay. You want to address the last after this discussion?
Not last. It will be an interaction with the panelists, what we have decided.
Okay. Okay. We have a slightly different format. Let me move forward then.
Okay. Yeah.
May I request our technical director, Dr. Nilanjan Gupta, to say a few words, sir?
Sir,
just to bless the evening.
No. Thank you, sir. I am very happy that the West Bengal State Center, particularly, they are organizing series of webinars, particularly in this Electronics and Telecommunication Engineering Division. And in fact, we are providing a lot of assistance to all the centers. And I request, because I think members from other centers are also attending this webinar. So any member, any corporate member, or anybody attached to our centers can suggest webinars of different topics to us. Please write to us at technical@ieindia.org. We shall definitely consider those topics if it is of interest of a large section of engineers. So with from this arena, I request everybody, all the members, to kindly suggest webinar topics of interest. So thank you, sir. Let us move on to the main program of the webinar, sir.
So thank you very much.
Thank you, sir.
And thank you for your continued help and support. And whenever I have some difficulty, I always request your help. Thank you very much for that.
Thank you, sir. That is our job, sir. Thank you, sir.
May I now request my colleague, Mr. Chanchal Chakraborty, Joint Convener, Electronics and Telecommunication Engineering Division Subcommittee, West Bengal State Center, IEI, to introduce our esteemed speakers.
Sir, before Chanchal Chakraborty will introduce, I would like to inform everybody that now we have crossed more than 100 participants in this program. So
That's very good.
I hope that within a few minutes, we will cross the 150 marks. So
Oh,
it's
very good.
encouraging for all of us. Thank you very much.
Thank you, all the participants.
Yeah. Chanchalda, please.
Chanchal.
So, thanks, Ramda.
Mhm.
Today in the and also I am really highly privileged to welcome our speakers in this within the presence of this august audience. I introduce here Dr. Nabarun Bhattacharya. He is the Senior Director and Center Head for Seedec, Kolkata. Dr. Nabarun Bhattacharya is a Senior Director and Center Head of Seedec, Kolkata. As I've already mentioned, he is a PhD in Engineering from Jadavpur University, Kolkata. He's a research scholar at ITMO University, St. Petersburg, Russia, and adjunct professor at IIT Kharagpur and Macau, Kolkata. His research interests span in the areas of sensors, IoT, AI/ML-based analytics.
Nabarun, I'm very sorry, I couldn't connect.
Professor Bromo, you please unmute. You please mute yourself. Right now the program is on. You kindly
Yes,
mute
I
yourself.
know,
Please
but
mute yourself.
I couldn't get in.
No, you mute yourself. It is already the people are.
Okay.
His research interests span in the areas of sensors, IoT, AI/ML-based analytics, high-performance computing, cyber physical systems. He is a pioneer of the design and development of electronic nose and electronic tongue systems in the country. In the agriculture area, he has worked on the characterization of the quality of agricultural products like black tea, aromatic rice using e-nose and e-tongue. He has explored his indigenous developed perception-based technology in the environment areas also. He has been leading in the ambitious program of DIT named Application of Electronics for Agriculture and Environment as Chief Investigator. Dr. Bhattacharya is authored or co-authored over 180 papers in the different international journals, conferences, and 12 book chapters in the electronic computer systems and pattern recognition. He holds 35 patents deriving from his research. He is the recipient of number of awards, honors that include CSI Award, Intel Award, and Seedec's Best Scientist Award. I am also having the privilege to introduce Mr. Alokesh Ghosh. He is Associate Director of Seedec, Kolkata. Mr. Alokesh Ghosh did his master's degree in radio physics and electronics from Jadavpur University of Calcutta. He has over 27 years of R&D experience in various domains of electronics and IC technologies. Presently, he is working as Associate Director in Seedec, Kolkata, and is looking after the agriculture and environment electronic group. In addition to the research projects, he has also done a number of industry projects for clients like Metro Railways, Eastern Rail Coalfields, BCCL, GAIL, NTPC, NCSM, FCI, and many more. His present areas of interest are embedded electronics, IoT, robotics, and AI. With this thing, I welcome Dr. Bhattacharya and Mr. Alokesh Ghosh. The platform is all yours. Thank you very much.
Good evening to all the guests on screen, because these days we don't have guests on dais. So on-screen guests and the members of institution of engineers and students and corporate members who are present in today's webinar. I am accompanied by Mr. Alokesh Ghosh with me. Just now, one of the panelists told that the participants number crossed 100 and it's 112 now.
112 precise.
Yeah, 112 now. So that shows the importance of the topic on which we will deliberate for coming 1.5 hours or 1 hour plus. And I am sharing my screen for that purpose. What is this? Can you see my screen?
Yes, Nabarun.
Yes. So what we have tried to compile here, our ideas and the recent research trends in this important area of IoT and AI, and the convergence of these two for the benefit of society and
Okay,
masses,
thank you so much.
especially
I'll do the rest. Thank you.
applicable for India.
Okay, thank you so much. Thank you.
Before going to my next slide, you may all know, but I'll repeat that IoT stands for Internet of Things. And Internet of Things means that any IoT device will essentially have some sensors or actuators in the front end, and this will have a processing electronics, because when there is a sensor in the front end, then sensor will sense some physical phenomena, maybe temperature, maybe relative humidity. And please know, when some physical phenomena is being sensed, it is being sensed from the nature or some process. And those sensor output will essentially be analog in nature. And then that analog data needs to be processed so that that data is readable by a computer or a digital system. So that electronic processing has to be inbuilt into an IoT. It doesn't stop here. IoT also will be having at its termination some communication device connected to it. So IoT is a combination of sensor or actuator, the enabling electronics, and some communication, maybe internet communication, maybe radio frequency communication, maybe any other modes of communication, wired or wireless. That IoT will have these three components. And AI, as the name implies, is in artificial intelligence, that is the intelligence possessed by the machines, by the computer. And that intelligence, to be really built into a machine, what is required is human intelligence. And human intelligence, once collected in the form of data and processed by human intelligence, that data form the learning algorithms for the machine. So artificial intelligence will come to life with machine having capability of learning. So machine learning is an integral part of artificial intelligence, and IoT actually collects the data or transmits the data to the nature. And once they converge, really the revolution like the ones you are witnessing today, that online revolution, the cyber world has been connected to the physical world, and that has happened because of this convergence only. With these initial words, let me tell you that myself and Alokesh Ghosh belongs to the organization called Seedec, and Seedec is essentially an R&D organization. Seedec started in the year 1988. Is having 12 locations now. Here it is written 11. It's a slightly older slide. 12 locations in the country with more than 3,000 scientists working purely in the area of ICT, electronics, and advanced computing. Seedec makes supercomputer indigenously in the country. That is not only used by our country, but also more than 25 countries other than India. They use Padam series of supercomputers made by Seedec. And Seedec being a premier R&D institute, we have got some identified thematic thrust areas, starting with high performance computing. Then we do a lot of work in multilingual computing. You know, India is a very big country with a number of language. People speak a number of languages and dialects. And unfortunately, if you visit China, you will get the computer usability in Chinese language. If you go to Spain, you will find Windows in Spanish. But India doesn't have the language enablement in our computer systems, and Seedec does a lot of R&D so that multilingual computing should be possible and available to the people. Also, Seedec does a lot of work in the area of professional electronics, software technologies with a focus on free and open source systems, cyber security, and not only cyber security, cyber forensics. That is, if a cyber crime is done, like conventional forensic, to go to the root of the cause of the crime or finding out the real traces left by the criminal so that they can be converted into tangible evidences in the judicial arena. Then health informatics and education and training. Now, our motto actually in Seedec, we work in advanced technologies, but science is the driving force for this kind of technologies. And science and engineering together actually are the technology. And our focus is not only to concentrate on science or basic research, or not only concentrating on the basic engineering, but to integrate them together to a technological solutions really usable for the people. And here, IoT and AI, they are actually the applied form of science and applied form of engineering, which we want to converge together for various societal verticals. Like, there may be a lot of societal verticals. Some of these speakers were talking of smart cities. Some of there may be advanced healthcare system, etc. But in Seedec, we look the most important societal verticals very relevant in Indian context are agriculture, health, education, governance, and environment related to agriculture, as well as the conventional environmental monitoring. So our efforts, our R&D in converging benefits and technological solutions around IoT and AI focus on these 5 verticals of societal importance, especially for India. And in this presentation, we will try to take you through some of the solutions that Seedec has tried to develop by converging the technologies of IoT, AI to really tangible, meaningful products, which may be or which have started being highly beneficial for these societal verticals. Now, this is a very favorite slide of mine. In some previous talk also, I might have shown you, but this is the circle of emerging technologies we must always try to keep in mind. And at the top, you can see that is Internet of Things, IoT, because that is the connect between physical world and your digital world. And once it is connected, then the artificial intelligence comes into play with enablement of machine learning. So machine learning is a subset of artificial intelligence, and that really gives a machine the decision-making ability using the data that has been collected by the IoT devices. And then, as we are talking of emerging technologies, this data collection ability coupled with capability of making decisions based on those data makes robotics possible. Now, robotics is autonomous, be it autonomous vehicle, be it a humanoid robot, they have to have IoTs as data collection devices, sensors, navigation aids, and artificial intelligence coupled with machine learning should empower the control algorithms that will make a robot work for a particular purpose. Suppose if you want to use a robot for agriculture purpose or seeding, sowing the seeds, or finding out whether a crop has been infested with some disease or some pests. So these robotic decisions, robotic controls, robotic motions, robotic missions that can be controlled by the AI and ML that has been embedded into the system. And once this data becomes very big and the velocity of data is very high, change of data is very high, when there is unstructured data which needs to be analyzed, then the special tools and techniques of big data analysis comes into picture, which really makes many solutions and many societal decisions possible, which wouldn't have been possible for us to really materialize or realize unless these tools are available with us. Then with IoT, with AI enablement, virtual reality and augmented reality are two areas which helps in various domains, in education or in health or even in entertainment. So these virtual reality and augmented reality also one has to keep an eye on when we talk of emerging technologies. Then of course radio frequency identification, RFID enabled devices, that is one more form of IoT devices which are in use for many of these solutions using this kind of emerging technologies. Blockchain is another technological domain which can handle data in a very secure format. And India is developing, Seedec is developing for India the Indian ledger and Indian blockchain framework for various applications like land record for the urban areas, for land record for the farmers, or even the food safety applications like traceability of agricultural produces right from harvesting to your plate. And I have also mentioned nanotechnology here because once we talk of Internet of Things, we talk of sensors, we talk of actuators, and we talk of electronic devices capable of processing data. And electronic devices are possible to be fabricated with the developments in nanotechnology on any chip, any electronic device, any sensor. They have to use nanotechnology, and not only nanotechnology, nanobiotechnology also, to really make the sensors useful for certain focused applications. And then I have told that IoT is at the end of IoT. It has to be communicated. It has to be able to communicate. And this communication technology also is evolving from 4G to 5G to 7G. So one has to keep an eye on these communication developments also, so that convergence of IoT and AI really brings affordable, usable, and user-friendly solutions for various societal verticals. So with this slide, I have tried to explain this circle of emerging technologies, which in short are called cyber physical technologies. These are the technologies which link the physical world to the cyber world. And at the center of all these technologies, the heart is the IoT and soul is the artificial intelligence, and convergence of them can really make wonders and really can solve many problems, especially for developing countries like India. So I have told all these things a little bit about nanotechnology, about 5G, 6G, 7G, what are the real features of this kind of technologies. I have told that Internet of Things. Please remember, it has to have a sensor or actuators at the end. It will have the processing electronics to convert the analog signal to the digital signal or digital signal to analog signal for actuator-driven things. And then it will have a communication also inbuilt into that. There are a number of protocols. We are not getting into details of that. With IoT, data collected, artificial intelligence will be really coming to life with machine learning, because you have to train your machine with the data collected from IoT to be capable of making decisions just like human being or slightly better than human beings when it comes to very repetitive things and huge data, or where the human error can happen if it had been done by human decision making. I have talked about a little bit of robotics with autonomous robots and humanoids are realities for various applications. Even you get robotic presenters in science museums. If you visit the museums in advanced countries and India also, in various science museums these days, they use robotic presenter who greets you with a humanoid, and then it will be able to communicate to you in your own language about the exhibit that you are looking at. Of course, big data, and not only big data, the resident big data on cloud computing also is the associated technology, which you have heard of, and you must have used such technologies in many of the applications. Virtual reality and augmented reality, these two things are very useful in educational domain as well as the entertainment domain. RFID are the tags. They are useful in keeping log or having identification of certain products or systems in the logistic domain. Blockchain is the most secured as of date way of keeping your data, and it has started finding many more applications. And all of you know that cryptocurrency revolution that's going on all over the world is anchored on blockchain technology. So in Seedec, our high performance computing, grid and cloud computing technologies around this Param series of computer, they solve a lot of these societal problems, because now HPC is available over cloud, and researchers or any stakeholders in these domains can access Seedec services and get the this kind of computing done with the data available for that particular. Suppose it is a disaster management domain or it's a agriculture domain, it can be done. And a number of applications we are working. One of the major ones I'll try to tell you about bioinformatics applications. And we have, Seedec has got, because biological domain has got huge data for the gene sequencing, genomics, etc. And one of the major groups, they have developed a number of applications which are being used by pharmaceutical companies or major stakeholders in the biotechnology and biology domains. These are the national facilities which are there in Bangalore, Pune, and they are accessible. And please go to Seedec.insight to find out details about all these things. These are the Param Shavak. There is a miniature version of Param series of supercomputers, which is available for any educational institute who will have a GPU-based system for doing for training or for R&D. So with this, we have worked for various societal domains in the areas of sensor sensing technology, wireless sensor network IoT technologies, of course, instrumentation and automation, web and mobile technologies, biosensors and bioelectronics. An application domain we have worked on agricultural climate, which includes soil, water, air around the agricultural ecosystem, food safety, its quality check, tracking and traceability, and of course, a number of applications in the domain of health, environment, and education domain we are not going to highlight today. We will be keeping us limited to agriculture, environment, and health. Henceforth, I'll request my colleague Alokesh Ghosh to take up and continue and acquaint yourself with a number of use cases where convergence of IoT and AI has been demonstrated in the form of products and solutions. Alokesh, you can take over.
Good evening. Thank you, sir. Thank you, the organizers, for the invitation. This is a series of products we have developed at Seedec, Kolkata, which are based on AI technology or machine learning technologies. I'll brief you about a few of them. This is an electronic nose and vision system. This was developed by Dr. Bhattacharya. It is a combination of electronic nose and electronic vision. This is for quality assessment of tea. You can assess it other than assessment of finished tea. It also gives a very important thing. Fermentation is a very important process in tea manufacturing, and proper endpoint detection or optimum endpoint detection of fermentation is very important for the producers of tea. This device can tell you accurately the optimum fermentation point. So that is another application of this device. This is based on pattern recognition techniques when we talk about electronic nose, and image processing techniques when we talk about electronic vision, and ultimately AI application, built-in AI application or machine learning application. It grades tea according to its quality, as well as it can give the optimum fermentation point. Now, this is my work. You can see that this is this device developed by Dr. Bhattacharya, which is a benchtop machine, which is not portable, and you require a computer or laptop for its operation. And as well as you require power, I mean line power, AC power for operation. Now, for field usage, which that device may not be suitable, so we plan to develop a handheld device which having all the functionalities of the previous one. So this is the device we have developed, my team has developed, and we have some spin-off applications also, like apart from tea, it has applications in jasmine and the extract of jasmine, which is called concrete, quality of jasmine and concrete. It can estimate the quality of some spices. We have worked with cardamom, and it can detect the oil content, the presence of oil content in cardamom. Okay. some other applications also we have developed. This has been, technology has been transferred, and the company is trying to sell this. This is, I'm skipping this. This is electronic tongue, originally developed by Dr. Bhattacharya and team. This is another application which is based on image processing. This is called, we name it Annadarpan. This is a device which can give you the quality of rice. Okay, and FCI is our major customer for this. They are using in different parts of India for while purchasing rice from the farmers or from the middlemen. Okay, so they check quality using this device. This is again an image processing based device, and the backend application is machine learning application. This is a similar device, but here it is converized. This is for chili and turmeric, determination of chili and turmeric. You know that Andhra Pradesh, particularly the Guntur area, is famous for chili. They also export chili to a large amount. So this device can determine or detect the quality of a particular sample of chili, and it can accordingly it can determine the price for the both for the sellers and the buyers. Okay, based on the quality. I'm skipping this. We have done some factory automation also, where we put a lot of sensors and actuators, and the communication is wireless, and it is a total an IoT system to check the to monitor the tea manufacturing process that at different stages, and to take particular control actions. At 3 places we have installed these. One is the Model Tea Factory at TRA Toklai Jorhat Tea Research Association, Kamalpur Tea Factory, and Brahmakunda Tea Factory. These 3 places we have installed this. This is web-enabled access of agricultural information. Actually, we developed this along with Bisha Agricultural University, Ranchi. Here for agriculture, animal husbandry, and forestry, we have developed application where a user through different means, through website, through his mobile, through SMS, through voice, he can ask questions, and solutions, online solutions solutions are provided to them, and it is developed apart from English and Hindi. Some local vernaculars are also developed. One of the major vernacular is Nagpuri, which is a major vernacular in the Jharkhand state. Right now we have a team who are working on biosensors. Here in biosensors, we are trying to detect pesticide residue in tea, and particularly the organophosphorus group of pesticides. You know that the trace residue of pesticides is a major problem in most of our agricultural produces, and if they found these traces beyond the permissible limits, they will just reject the consignment in total. So rapid detection of these pesticide residues is very important. Our team developed the biosensor, which is based on colorimetry, and as well as electronic circuits are also there. And another similar work we did for fruits and vegetables, which was funded by RD Tata Trust. So here colorimetry means colors are developed after you put the sample on a particular solution. Sample preparation technique is there, which is very fast. You require only 5 to 10 minutes for sample preparation. Then the color changes, and according to the change in color, we can understand whether pesticide residue is there, what is the level in some few discrete levels. It may not give you very, very accurate results, but it can give you estimate yes, no sort of thing, whether it is beyond the limit, permissible limit or not, and so that you can take decisions on this. And again, this is image processing based colorimetry technique. as well as biosensors is the development. And now what we are doing, we are integrating communication with each of these devices, so that wherever you are doing the testing, the data can be uploaded. If you have connectivities, the data can be uploaded to our server or cloud, and there the analysis can be done, and data can be stored, and in future reports can be taken. Or skipping this, this is a project for water quality monitoring. This is under BRICS program. You know what BRICS is, the conglomeration of Brazil, Russia, India, China, and South Africa. This project is going on. We are doing a similar project with Swiss, the name Swiss, which is an Indo-Denmark project where we are trying to detect heavy metals in water. I'm not going into details of the other products. We have a nationwide spread of collaboration. This is the list is incomplete. We are working with more than 50 collaborators. Some of the collaborators are technology collaborators, and most of the collaborators are domain collaborators. And normally, whenever we take a project, since it is agriculture and we are not agricultural scientists, we are mostly in Seedec, we are either electronics or computer science engineers. So we need to consult domain expert while working with agriculture, in the field of agriculture. Apart from national collaborators, we have, as in my previous slides I showed, we have a few foreign collaborators also. So as a conclusion of this, we call it Agriculture 4, where we need to leverage on multidisciplinary cyber physical technologies. Already Dr. Bhattacharya mentioned that we need to leverage on technologies like IoT, like artificial intelligence, machine learning, big data analytics, image processing, and artificial intelligence. So areas of research would be AI-enabled national digital platform for multimodal, multilingual information dissemination, IoT and AI-anchored digital framework for precision farming. I will come to precision farming, sensor-based soil fertility monitoring, and we have also started working on robotics and mechanization, particularly for the field of agriculture. Now, actually, the earlier portion was Dr. Bhattacharya's part. Now, I started from here, convergence of IoT and AI, artificial intelligence in agriculture. So, what I will do, I will briefly cover the general discussion on Indian agriculture. I will talk about precision agriculture and related technologies. I'll talk about a few case studies, mostly from India and from Seedec's case studies, as well as one from Japan. And I will also talk about Seedec initiative on agriculture robotics. And finally, since we are talking about convergence of IoT and AI, we'll try to see where the world is moving forward in near future, in terms of society. I mean, what kind of improvements it can do for individuals and for the society. Briefly, I may not have time for an elaborate discussion, but just I will give you the concept. So the challenges, the first challenge is population explosion. As per UN report, the world population will reach 10 billion by the end of 2050. So the world needs to produce 50% more food. By 2050, whatever foods now we are producing, we need to produce 50% more food. And if we talk about cultivable land, only 4% of additional land will come under cultivation to meet this demand. So it is hugely challenging task. So what we need to enhance productivity. We need to enhance productivity, we need to minimize the waste. The second challenge we are facing now, we have already started facing, that is the challenge of climate change and global warming. We are encountering more and more unpredictable weather conditions like heat waves, like storms, abnormal rainy seasons, cyclones, and the winter is getting more and more cooler. And if this is going on, as per prediction, India is going to lose 20 to 40% agricultural land by end of 2050. So we need to produce 50% more food, whereas we are going to, because of climate change, we are going to lose 20 to 40% of land by end of 2050. Secondly, these heat waves, it can produce extreme heat stress in crops, which will cause yield loss of yield. Similarly, whenever cyclones and heavy rains are occurring, it results flooding, and that will be detrimental to crops and to the soil structure. Another point, because of this extreme weather conditions, weed and pest proliferation is encouraged. So pest management becomes less effective, and we need to put higher amount of weedicides and pesticides. So cost will be enhanced, and our since we are adding more pesticides to the field, will add to the pollution. So sustainability will be lost. And thirdly, we are very much concerned about farmers' income in India. As per a Financial Express report 2018, the average annual farmer income remains at around 78,000 per annum. Let us now discuss about the problems of Indian agriculture. We know that Indian agricultural land holdings are small and fragmented. We are putting, we don't know, the farmers don't know how much fertilizer is required. So they put excessive amount of fertilizer, which effectively degrades the land. And finally, the outputs are dependent on external factors like weather condition, water resource, pest and disease attack, etc. And we are not having enough mechanization in our agriculture practices. Our farmers are very slow in adopting technology. Already I have mentioned environment pollution and climate change are a few factors. Inadequate and improper storage facility is again a problem. We don't have adequate and proper storage facility. Actually, we worked in a project with FCI where we tried to see the environmental conditions. Just 1 second, please. The environment conditions in a warehouse, and try to provide solutions to them using IoT technologies. We monitored temperature and humidity at different corners of the warehouse, and try to correlate the crop conditions, the stored crop conditions with the environmental variations. And marketing is another big problem, big issue in India. Marketing of the end produces. In a nutshell, agriculture is not at all a lucrative profession. People, particularly the youth, the educated youth, they are migrating from rural areas to urban areas to earn better wages. So there are shortage of farmers, shortage of even labor, because laborers are also moving to cities for better wages. Environmental pollution is one of the major issues, because we are putting uncontrolled fertilizers, uncontrolled pesticides to the field, which is adding pollution to soil, pollution and It is just the runoff is going to rivers, lakes. So water pollution is also being added. Food safety is compromised. As I already told that we are working to detect the pesticide residue in some vegetables, in tea. So in whatever vegetables, whatever food we are having, I mean, more than 90% of them are having pesticide residue levels beyond limits, beyond permissible limits. And since the farmers, they themselves, farmers or laborers, they themselves spray these pesticides and herbicides, obviously there are health hazards because of this spraying. Now, let me talk about precision farming. What is precision farming? Precision farming tells us that if we can divide the farm field into some imaginary grids or cells and try to find out the variabilities in each of these cells or in a group of cells, and then treat each of these cells as per its requirement. That is the management decisions. Now, you can see that using GIS, we have shown one particular field, and some of the we have divided this particular field into some imaginary grids, and some of the grids are marked red, some of the grids are marked yellow, some green. Now let us consider that this is a field. This is the red grids means that the soil is infertile. The green means the soil is fertile. Yellow means it is in between red and green, and all other colors are in between red and green, the extreme two, the totally infertile and fertile. So whenever we want to put fertilizers, we need not put fertilizers in the green region. We need to put fertilizers in the maximum fertilizers in the red region, some less amount in the orange region, likewise. So that we can save a lot of money from this by using controlled application of fertilizers, as well as we are not degrading our land. We are not degrading our land, because already I told that if I put excessive amount of fertilizers, that is going to degrade our land also. Now, precision fertilizer, precision farming, the key technology is IoT and AI. The backbone is IoT. Dr. Bhattacharya already told that the IoT is consisting of some sensors or actuators. So we need to monitor the field properly using those sensors. We need to analyze the data using some AI algorithm or some machine learning algorithm. And finally, we need to act. That is, we need to, wherever we will find less amount of fertility, we need to put fertilizer in that particular region. So that is action. So there are three components in any IoT and IoT AI application, that is monitor or capture data, analyze the data for decision making, and finally act or control. And the bottom line is to do the right thing in right place at the right time. And AI plays a very big role in this, in IoT applications, because IoT only captures data and send it to some server or cloud. So there, the role of AI is to analyze the data, to bring some insight from the data and tune the and based on the insight to tune the parameters as per the requirement to get more and more productivity at a lesser price. So bottom line is right thing in right place at right time. Benefits, these are the benefits. Productivity will be more, prevent soil degradation, reduction of chemical application, efficient use of water. Water is very, very costly. So efficient use of water is very important. Improves quality, reduces cost of production, reduction in volatility and risk, yield estimation, and helps in crop insurance assessment. Overall, it can change the socioeconomic status of farmers. For precision farming, these are the technologies. IoT, already we have discussed what is IoT and how it can help in precision farming. Robotics, it is also based on IoT because in robotics, we are having sensors, we are having communication, we are having artificial intelligence, all of this. So in we can send an autonomous vehicle or autonomous robot in the field to carry out certain operations, and after doing all the operations, it can come back to a place precisely doing the operations. The third very important technology is GIS and GPS. Okay, so mapping the exact, the precise position of each of the cells is very, very important. While we are doing precision farming, either using IoT or using robotics, knowledge of the location of each and individual grid, each of the grid is very, very important. And for this, the tool we are having, the software tool we are having, the GIS mapping, and for positioning, we have geographical positioning system or GPS. The GPS which we are having in our mobiles, you may not use those kind of low resolution GPS in this particular case. You may have to use some high resolution or high precision GPS devices for this kind of application. Another very important thing is weather information or real-time weather information. We have done one project using our supercomputing infrastructure, where we can it can predict in a 4 kilometer by 4 kilometer grid, that is in a panchayat region, it can give the accurate weather prediction for 24 hours and 3 days in advance. It can and around 10 to 15 parameters it can tell about rainfall, about wind speed, wind direction. It can give hourly prediction, all of these things. So that is one application already we have developed. And finally, the key is artificial intelligence. So whenever we talk about IoT or robotics, it is not IoT or robotics alone. The backbone or the brain is the artificial intelligence. IoT already we have discussed. These light green colors are the nodes. These nodes are made either with sensor or actuator or both. So these nodes are connected to the deep green regions, which are called hubs. From hubs, it can transfer data to the orange region, which is called the gateway. And from gateway, there is a very, very strong connectivity to the cloud or to the servers. So these sensors and actuators, they are collecting data from the process or from the field, from the nature. It transferred the data to the hub. From hub, it can goes to the gateway. Gateway is close to the sensor or actuator nodes. And finally, from gateway, it sends data to the server or to the cloud, where the data is analyzed, decisions are taken, and for control action, it is just sent to the gateway again, and gateway will send it to the particular node where the decision has, where the action has to be taken. So this is the structure of IoT. I'm skipping this. Irrigation system, fertilization system, early disease detection and pest control. This is very, very important. And in most of the times, our farmers are totally helpless when there is any disease attack, or whether in case of any pest attack, they become totally helpless. So IoT can be a very good tool for the early disease detection and pest control. Fertilizer already I have mentioned, and irrigation is another area where IoT has many applications, and there are a lot of applications people are trying to do in irrigation. Why irrigation? Because water, already I said that water is very, very expensive, and it needs to be applied carefully, because in our country, almost 60 to 70% of total water usage is in agriculture. 60 to 70% of water usage is in agriculture alone, and out of which 50 to 60% is simply wastage. The farm field doesn't require that much of water, but we are helpless. We are just putting the water, and that is just drained away. So carefully we need to put water onto the field. For this, what we can do, we can put soil sensors to check the soil moisture levels. We can put sensors to check the plant conditions, and accordingly we can apply water in a very, very controlled way. That is, that will put that much which is required by the plants. Now, technologies are okay. Technologies are very good. IoT is very good. IoT as a technology is excellent. Robotics as a technology is excellent. But these technologies are not being proliferated in our country. You just consider robotics. You keep aside agriculture. In how many industries people are using robots? This is because they are very, very expensive. All these technologies are expensive, and the ROI is very less, particularly in case of robotics. So what we need to do as a researcher, as an innovator, what we need to do, we need to apply this, try to apply this technology in an intelligent way or in an innovative way. Now, this is one use case. We worked for the tea industry. This is IoT-based precision farming. Decision support system framework for tea plantation. We worked it for, we did it at Interior Toklai and another tea plantation garden in Assam, Jorat. Here, we put a few sensors like soil moisture and pH, ambient and soil temperature, humidity sensor, solar radiation, leaf moisture, and to check the insect invasion and disease, we put a couple of cameras on the tea plantation or in the tea garden in a particular region. Now, what is find that if we want to put if we make the grids very small, and if we want to put the sensors in each and every grid or in a group of grids, then the cost will be huge. The planters are not going to, they cannot afford this much amount of money for this kind of operations. So what we did, we instead of putting sensors in each and every place or each and every grid or a group of grids, what we put these wireless sensor networks or these IoT sensors in a few grids in some strategic location, which was guided by the domain expert, that is the tea planters. As per their suggestion, a few sensors we put on the field, and we developed one soil sensing kit. So what people need to do, these sensors, whichever we put on the field, they are giving us 24/7 data. And for the rest of the field, one person need to go once in a week, they put the sensors, they take the data, and we have developed one application, one mobile application using GPS, using GIS and GPS. The kit also was having a GPS. So what the operator need to do, he need to put the sensors on the field or wherever he needs to put it. He puts it, he puts on his mobile application, and automatically from the GPS, the coordinate or the location of the particular site comes, and the values are entered, and those values are directly transmitted to the server for storage and analysis. So by cleverly making IoT along with a soil sensing kit, which a manual operation is required, that is a hybrid mode. We can the cost of the expense was brought down drastically, so that the tea garden, they could afford this installation. This is one application we have already started. We have started building the POC. This is for dairy. Now, under agriculture, this animal husbandry. In today's world, animal husbandry comes under agriculture. That is dairy, piggery, poultry. All of these comes under agriculture. So, what we need to do here. And now the dairy sizes are very, very big. The dairy sizes are very, very big. So monitoring each and every cow for health is a difficult, very, very difficult proposition for the dairy manager or the dairy owners. But if you cannot detect disease early, you cannot treat them properly, and you will have huge amount of yield loss. So this particular project we are doing with National Dairy Research Institute Kollani, NDRI Kollani. What they suggested that we need to monitor these few parameters 24/7. What are the parameters? Body temperature, pulse rate, rumination rate, lameness, and heat detection. So these are the 5 parameters we need to monitor. So what we planned, we are planning to put some collars on each individual cow, and in that collars we'll put some IoT devices, and sensors will be mounted in these devices, and these sensors will give us the body temperature, pulse rate, rumination rate, etc. And we'll transfer this data through some communication link. For this, we are targeting 2 technologies, 2 communication technologies. One is LoRa, and the other one is BLE, low energy Bluetooth. So we'll try which one will give us better performance. So we'll select that. Now, as per the you will be surprised to listen that if we can monitor only the rumination rate properly, that can tell us, that can give us clear indication of the well-being of a cow. So only by monitoring the rumination, this is as per the suggestion of the domain experts, that only by monitoring rumination rate, you will have a pretty good idea about the well-being of each and individual cow. But we are going to monitor all these parameters. So right now we are at POC level. This is another project we have taken. This is with Poultry Directorate of Poultry Research, Hyderabad, where we are monitoring the environment of the poultry, like temperature, relative humidity, carbon dioxide, ammonia, atmospheric pressure, airflow, and light intensity of the environment in the poultry farm. And along with this, we are trying to using artificial intelligence. We will try to correlate with the well-being of the well-being of the birds, as well as the stress developed by these parameters, by variation of these parameters on the birds. So this project, we have also this project we are in the design phase of this particular project. This is for fishery. This is with CIFRI Barakpur, Central Inland Fishery Research Institute Barakpur, where we are using IoT sensors. We are trying to monitor water temperature, water conductivity, water level, dissolved oxygen. This is very, very important for the fish well-being, oxidation reduction potential, and water pH. By monitoring these parameters, we are trying to correlate the fish behavior along with this, and how these parameters, how fish are stressed by these variations of these parameters. So these are the, right now what we have done, we have installed 2 systems in the experimental tank of CIFRI, and we are trying to monitor the parameters And later we'll put artificial intelligence to correlate with fish speech and behavior. Now come to some robotic solutions. We have heard about autonomous tractor. Yes, fully autonomous tractor is a reality now, but for India, we cannot even think of this because of its very exorbitant price. But unmanned aerial vehicles or the drones, they are being used in India, in many parts of India. They are being tried for fertilizer spraying, for pesticide spraying, using camera-based sensing and spraying accordingly. So these are being tried. This drone is being tried at different places in India, but autonomous tractor, it's not a reality in India. Since time is not much, I am skipping this particular case study. Now I'll tell you about the Seedec initiative on agriculture robot. We proposed a project to our ministry, that is Ministry of Electronics and Information Technology, that we want to build one autonomous field robot for paddy cultivation, for different operations of paddy cultivation, and we want to build the robot as fully autonomous, so that I can tell the robot the path it has to follow. The path I will tell it what are the operations it need to carry out at what places it will carry out, and it will come back to me after doing all the operations. So this is a very ambitious project, and in this project we had along with us we had IIT Kharagpur, Kumaraguru College of Technology Coimbatore, and Bitsa Agricultural University Ranchi. They are our domain expert collaborators. Duration of the project was 2 years. IIT and KCT has different roles in this, not developing this particular robot or vehicle. It is purely a Seedec's role to develop these vehicles. They had other works to do in this project. So I am not discussing on their role. I am only talking about what Seedec has done in this project. What the robot needs to perform? It has to perform autonomously. The operation would be autonomous, and it has to be operated through remote control also. It has to go to the field from 0 to 55 days of operation. After 55 days, the domain expert said that you cannot put a robot into the field or a vehicle into the field because the plants grow very tall. So up to 55 days, you require the cultivation processes are going on for paddy. So up to 55 days, it need to go to the field. One point I want to mention here, that this particular robot we developed for direct seeding variety of paddy. Nowadays, we know that normally paddy plants, the young plants are transplanted. It is developed at one place and then it is transplanted to the real field. Now there is another variety which is the direct seeding variety. Now it is very fast, it is getting popular among the farmers. So we are targeting the direct seeding variety of paddy for this. Crop scouting is another very important operation during the entire cultivation period. The farmer need to go to the field every day. He need to check his plants whether they are affected by any disease, whether they are affected by any attacked by any pest. So this scouting is very important for this operation. And finally, spraying of weedicide and pesticide, controlled spraying of weedicide and pesticide as per requirement. Now, what are the challenges? What are the challenges in developing such autonomous field vehicle for paddy? First challenge is the ground clearance. Domain experts said that you at least 1.1 meter should be the ground clearance of the vehicle, so that it without disturbing the paddy plants, it can go in between the two rows of the paddy plants or damaging the paddy plants. So for this, what we require precise navigation and heading accuracy of the vehicle. You see from the diagram here, you can see that in conventional practice, the rows are in 200 millimeter apart. Two rows of plants, two rows of paddy plants are 200 millimeter apart. So, and in our design, our wheel is 60 millimeter wide. The width of the wheel is 60 millimeters. So very, very precisely, it has to move through this in between two rows of paddy plants. Secondly, real-time decision-making and actuation. In all earlier cases, what we have observed in while using IoT, that we are sending data to the cloud or to the server. Decision-making, it is a huge computing infrastructure where you can take decision and you can analyze the data, take decision, and then you can send back the whatever action need to be taken, that can be sent back to the end device. But here, since it is a robot moving into the field, what we plan to put an onboard computer on the robot, because if I need to send data to the cloud and after it gets analyzed onto the cloud, and then decision was made and decision was sent back to the robot, it cannot perform in real time. So for real-time decision making and actuation, we put an onboard computing board on the robot. So this robot has to be high performance. So we put a board which is having, apart from the CPU, which is having GPUs, graphical processing units, a number of graphical processing units, so that it can analyze data very fast, and it can give decisions, or actuations can be made very fast, almost in real time. The fourth challenge is navigation or movement of the vehicle in muddy water-filled farmland, particularly in clay, where the soil is of clay type. It is very, very difficult. And since it is an electrical vehicle, 3-4 hours, minimum 3-4 hours operation is required each day in successive charging of the battery. So that is again a challenging thing. This is the major components we have used in development of this 48 volt 200 watt BLDC motor as drive motors, 48 volt 400 watt step servo motor as steering motors. So just to mention that this particular robot which we have developed, it is of holonomic drive. That means all the wheels can be driven and all the wheels can be steered. Okay. And battery, we have used a 48 volt 160 ampere hour lithium and rechargeable battery. For crop scouting, we used a few GoPro cameras. RTK GPS we have used for precise navigation. Normal GPS won't work here. We used RTK GPS for this. RTK GPS is called real-time kinematic GPS. If you go and try to buy an RTK GPS, it is very, very costly or expensive. Tens of lakhs it may cost. But here we used a very low-cost module, low-cost GPS module, and we built the entire circuit ourselves. Actually, in RTK GPS, you require two GPS receivers. One is called the base and the other one is called the receivers. Base is placed in a known location and receiver is placed on the moving vehicle. So the receiver, the rover which is placed on the vehicle, it makes correction using the BCS, using the base GPS data, and it gives very, very precise locations, which is sub-centimeter level accuracy it gives. For IMU, we use a BOSS IMU processor. Already I have mentioned it is a Jetson TX2 processor we have used. and a few controllers, Arduino Duo controllers used for different purposes. This is how the cameras are fitted and how we have put a sprayer, pump and tank for spraying of pesticide and fertilizers, liquid fertilizers. This is the architecture. On the vehicle, we have put the NVIDIA Jetson TX2 board. It is having an ARM Cortex processor plus 256 core GPU. It runs on Linux Ubuntu 16.04. For software development, we need to develop a very, because there are a lot of applications. I mean, we need to control the steering, we need to control the drive motors, we need to control the drum seeder for seeding, we need to control and fetch data from the camera, we need to, for proper navigation, we need to take data from the rover RTK and the IMU, we need to control and manage the battery, we need to control the sprayer. So all these operations are there. So the software has to be very, very modular. For designing this modular software, we employed a robotic operating system for this purpose, for real-time performance of image processing applications, because through image processing, we monitored the health of the plants, as well as whether the plants are diseased or not. For this, we used CUDA on this GPU. CUDA TensorFlow on this GPU so that it can be very fast, and the entire application is written in C and C++ and Python. So in the left hand side, you can see this is our control station from where we can control the robot either using some joystick, or we can give a command that you follow this particular path, do these operations, and then come back to your original place. So this is the graphical user interface in the control station. And in between control station and the robot, for communication, we have used long range Wi-Fi for this. The range of long range Wi-Fi which we have used, it has given us very good performance in 1 kilometer or 1 to 1.5 kilometer, but as per specification it can be increased to 5 kilometer also, so that it can cover a huge agricultural field. This is the software architecture, which is ROS, which is very modular. I am not going into details of this. This is the user interface. You can see that I can see the plant growth from this. I can see the position of the robot where it is right now. I can see the chlorophyll content. Chlorophyll content gives us the idea that whether nitrogen fertilizer is required or not in that particular place. Seedling count, how many we are putting direct seeding. So how many seeds has been developed from this. So seedling count is very important, and disease detection. So all of these things we can have. I'm showing a small video. This is at our office. This is the robotic vehicle we have developed. Recently, we have done the field trial at Birsa Agriculture, in the real field of Birsa Agricultural University, and we are planning some problems is with the structure of the robot, the structural stability of the robot. So we are planning a second phase where instead of battery, we are planning a electro-hydraulic system, and we are going to use an engine for powering or driving this vehicle. So that is in our plan. You see the thickness of the width of the wheels, which is very less, and it can go precisely, it can move precisely, and it can go to any direction. It is a fully omnidirectional video. It can go forward, it can go backward, it can go sideways. So that's, I'm stopping this. Now bottlenecks, coming to bottlenecks of these technologies, particularly robotics. You require considerable amount of investment. It is a very, very expensive, and it is a really an expensive affair for the small and marginal farmers. Operations are very, very complex. It requires technical expertise to skilled personnel to actually maintain these devices, and power. You require to charge the battery of this device overnight. So power cuts is a problem in rural India. So those are the bottlenecks. As a concluding remarks, I mean, whatever devices are available abroad, they are exorbitantly very costly. So we need to build our own technology. Only Indians, or only us, we can understand our Indian agriculture in a better way, and we can develop devices for our farmers or agriculturists. Combating price, if we develop on our own, obviously price will be much less. The small farmers or marginal farmers, they cannot buy these kind of systems because it will be costing around 10 lakhs. So community farming is required. It can be as a service. It can be deployed to fields as a rent. The way people are using tractors, or marginal farmers are using tractors in rural areas. Ecosystem to be developed for support and maintenance, and we need to attract educated rural youths into agriculture. And obviously the government has need to put a lot of initiatives and make policies so that more and more people can come and try these kind of innovations and proliferation of these kind of technologies for the betterment of lives of our farmers. Finally, I mentioned I mentioned that I will come to a conclusion where our world is moving forward in next few years, or in a decade from now. We know that society 1 or industry 1 is the hunting society. Then came the industry 2, or the agrarian society. Human beings, they learned how to do agriculture. Then came the industry 3 or the society 3, when industrial revolution took place. And finally, in the last few years, last 30-40 years, we saw the explosion of digital world, which is known as industry 4, or some people call it industry 5. It is I mean, everything is digitized. We have everything on our palm top through mobile phones. We are in the internet through phones. So we are now in the era of industry 5. Now, as per the Japanese, the world need to go to society 5. Society 5, this is an idea or the model given by the Japanese government in 2016. And this is a research initiative of Hitachi, the company Hitachi, along with University of Tokyo. And on January 22, 2016, the government of Japan released the idea of society 5. And later in 2017, this plan was unveiled to the world. Okay, now what is society 5? Society 5 is nothing but a people-centric or a human-centric super smart society. The vision is, it would be a science and technology driven society. And the goal of this vision is it would be a people-centric society. Okay, so after listening to this, the plan of this Society 5 from Japan government, the United Nations Development Program, they have in their development program, they have included the concept under Sustainable Development Goals or SDG, which has a bouquet of 17 goals, which are very, very similar to Society 5. So the bottom line is, whatever technology innovations we are going to make using IoT, using robotics, using big data, using artificial intelligence, machine learning, blockchain, whatever technologies we are going to build, we are going to build this for the betterment of humankind, for the betterment of each and every individual, as well as collectively for the society, irrespective of their age, irrespective of their gender, irrespective of their economic status, irrespective of their geographic location. So that is the idea Japan government was having, and it was taken beautifully by the rest of the world. Even India is planning to implement these kind of things in their future plans. So what is Society 5? For Society 5 is a purely human-centered or human-centric society. The expected outcomes are quality life with convenience, security, and safety. With comfort, that is, life will be happy and full of fun. Vitality, people will be liberated from their mundane work so that they have more free time to do their leisure work, to do their hobbies and other things what they like they will nurture hobbies, arts and music, they will watch films and matches, they will read books. So that is the basic idea of Society 5. And the indicators of happiness, are socio-economic conditions, which includes wealth, which includes income, work, housing, education, security, and safety. The second indicator is health, which includes both physical as well as mental health. And the third indicator is relatedness. That is how much I am related or bonded to my family, to my friends, to my community, and to the external world. The features of Society 5 is number one, sustainability. Whether through innovation we can make our world sustainable, and it is extreme convergence of cyberspace with physical space. Interconnected service, that means in Industry 4 we have many applications, but all of these applications are isolated. But in Society 4, all technical applications, all technology-driven applications in the cyberspace and in the physical space, they will be interlinked. They will collect data from one another, and using that data, they will build integrated services, integrated solutions for the betterment of, for the overall betterment of a particular area and in general for the humankind. This Society 4 is a data-driven and knowledge-intensive society. And finally, it is very, very important that we need to, all of these technologies are artificial intelligence technologies. That means the technologies are like a black box. We are getting some data from the sensors, from other sources. We are putting the data into the black box, and we are getting some output at the in the form of some decisions. But internally, what is happening, we are not knowing. So how can I trust this system? So to get trust, to build trust into these AI systems, we require transparency. For this, one technology is coming now, which is called explainable artificial intelligence, which not only give you the decision, but also it will tell why and how it derived to this decision, which is very, very important. And finally, Society 5 requires us to reframe two kinds of relationships. relationships between technology and society, technology mediated relationship between individual and society. That is again very, very important, because I said that it is going to be a very, very happy society. That means as an individual, I may like to do whatever I want, but I also need to check whether I am going to do any harm to the society. So this relationship is very, very important between each and every individual and the society, and technology can play a very, very important role in this, along with the help of social scientists. So that's all from our part. Thank you very much. We are open to questions now.
We have in the audience Dr. Aloknath De. I know he attended for some partial time. Dr. De, may I request you to say something about this? Whatever you...
No, it's a very nice presentation. Dr. Nabarun, I was listening, I think at 7 o'clock or something, I joined. There are very interesting things, and one is this future of farms that we talk about, and you get a glimpse of whether the dairy part or even certain other parts of the whole field. And so yes, it is not all applicable yet in India, but there are some microbots that are coming. There are these tractors, drones, and even we were seeing an example of pregging cow, pregnant, or if you are running a big farm, and you could get texts out of that, because you cannot monitor an ill health of a cow if it goes down. So these are interesting examples. I'm sure, to make it all pervasive, it takes a bit of time. So this is a very nice, examples. And you talked about various technologies also, like LoRa being used. And in other applications, there are Sigfox and other convergence technology. But that's interesting. On this AI and IoT, not on the farms and agriculture, but we also see, examples of in the sports, for example, we build these wearables, and inside the wearables, we have kind of, accelerometer, gyrometer, magnetometer. So if we can bring some of these, there has been already a smart bat, but cricket balls, a company in Australia, Kookaburra, who has built embedded these sensors inside the ball. And so you can see the speed, you can see the spin of it, and it's becoming an interesting. They have given it for certification. Hopefully, even in the real games, it will come into play. It helps novice players because they could judge it against the expert players, but it can also be expert players, but studying the opposition and making their own strategies to do it. So these are very interesting how AI and IoT could be combining. And I have done in Samsung from smart home context, that is all the digital appliances together at home, and how can we connect and then give some recommendation, give some automation features so that, for example, if you have forgotten to turn off the geyser at first floor, you could do that from the apps. And now we have done car to home connectivity. So even if you have left home, from the car itself, you can turn it off, the geysers or some oven if you have forgotten. Earlier, these were a concern and you had to come back. So a lot of interesting applications of AI and IoT together. And it was a very nice presentation that I was patiently hearing. These are some quick comments. And it's pleasure, to be part of IEI Council that I got elected during the last elections. So electronics is my field, and I would love to have more such sessions together. So thank you. Thanks very much.
Thank you, Dr. De. I'm a very big fan of yours because I have seen your presentation. So I thought you are the right person to be at the right session. Then we look forward to have session with you.
Thank you. Thank you very much.
Thank you. May I request now Mr. Santosh Kumar to Mutha to say something?
First of all, I would like to thanks Mr. Bhattacharya ji, Dr. Bhattacharya ji, then Mr. Ghosh sir for giving such a very nice presentation. And the topic of IoT and AI is really a very good topic which West Bengal state has been selected. I appreciate on that. And the part what I was listening of Mr. Ghosh is basically it was an agricultural part, what I felt. But the thing is that the relationship between IoT, machine learning, and AI, which is been demonstrated through many research, what these people have done, Dr. Bhattacharya have done, Dr. Ghosh, Mr. Ghosh has done, to develop a product and service, which the product they shown, it was really a very good product. I thank them for actually showing this particular thing. Secondly, I wanted to tell them that this is one part. Agriculture is a part of IoT and AI. I would like to have more stress on smart healthcare, which right now it is a very, because of this COVID-19 pandemic, it is very important to have something on smart healthcare. This was one part. And second, even the India and the other countries are also having a driverless car, wherein no robot will be there. The total car will be programmed in such a way, using the sensors and all those things, so that they won't be having any driver. It is known as driverless car. These are part which I request Mr. Bhattacharya, even Mr. Aloknath Dey, what he told that the spinning of a ball, it will be important for umpire also to see, to judge whether he is LVW or not. This was the important part. So they can enlighten us on this issue. Thank you very much. Thanks a lot.
Yeah, thank you very much, sir. We will be taking care of your this. Next time we'll like to organize seminar on health care and other issues. Okay, may I now request Dr. Professor Girish Srikishan Mundada to say a few words.
Yeah, good evening. Am I audible?
Yes, sir.
Yeah, it was really a fantastic session listening Dr. Bhattacharya over the inventions that are coming up. And these are all interesting and very much enthusing the young generation. I myself, being a professor into university, see all these kinds of technology development happening, and they are now included into syllabus as well. So younger generation is looking forward to this change, which is much needed. And as rightly standard is being put, they are understanding its relevance better. And as I understand from all this discussion that cost is becoming a limiting factor to take it forward in a cost sensitive country like India. But these prototypes and being into a very minor scale production currently, cost is a concern. But as India has taken a right initiative of this silicon fabrication and adopting all these standards, maybe in time to come, this will become very much affordable, like we have seen the revolution happening in mobile sales, right? Cell phones, same will happen. So really fascinated to hear this lecture and further more comments from Dr. Aloknath Dey. These are very good resources we have in our divisional board. So really happy to connect with you all, and wonderfully the right topic is taken by WBSC for this discussion today. Thank you very much.
Thank you very much, sir, for your time and for your suggestions. Now, let us move to the question answer session. We have 12 questions on this. The panelists, can you have a look at the chat box, or I can read it also for you?
Okay, I'll see.
You can see?
Yeah.
Okay. Then can you please just try to?
First question to Dr. Nabarun.
Uh-huh.
Could you please tell us something on the integration of various channels, the communication of various, I didn't get it properly, but
I think
channels,
what did it mean that is so many communication devices are there. So how you can help? But IoT must be number of IoT devices.
Yeah, actually,
nowadays wireless communication is possible, and you can always.
Actually, in any such developments, either we take one particular communication technology, whether it is a Zigbee sort of protocol, or it is a LoRa sort of protocol, or it is Wi-Fi, or it is Bluetooth, or it is BLE. So there we'll put what we'll put. We have some in nodes, as well as we have some hubs, we have some gateways. So data goes from sensors or actuators to node to the hub, from there to the gateway, and one gateway may have number of channels, number of sensors connected to this, number of hubs connected to this. So gateway takes care of this. I mean, the gateway and the underlying technologies, they take care of this communication channels and all these things. Now, second question is artificial nodes. Dr. Bhattacharya, are you there? Actually, he has left office.
Yeah. I'm there.
Now, can you read the chat?
Yeah, I cannot read in the mobile. I cannot.
I'm telling.
Okay.
Artificial nodes, can it differentiate between natural and artificial products?
Yes, it can definitely, because this artificial products, artificial nose senses smell and odor, and smell and odor is formed by the volatile organic compounds, and volatile compounds being emanated from the target substance. Now, the natural product and artificial product will have a different profile of volatile emission pattern, and certainly that can be sensed by the array of sensors, and the smell signature, smell print can be analyzed through advanced pattern recognition algorithms, and it should be we should be able to decipher. For example, for aromatic rice, we have seen that intrinsic flavor, they can be very clearly differentiated.
Okay, I hope you got the answer. The next question is why IoT is very important. Should I need to answer this question?
It's very okay.
Okay, I'm going to the next question. Any feedback of Bengal paddy produce quantity versus 800 rice mill sufficiency storage wise, including any potential of self-generating captive power? I didn't get this.
I mean, he wanted to say we have Mr. Shen, you were there already? Mr. Bhaskar Shen? Can you please unmute and ask the question, explain the question? I think he's not there. My feeling is they have some storage space and other thing. He said we have to Bengal produce so much of rice and 800 rice mills are there. And then why you potential for self-generating captive power? Of course, there is a potential because almost all rice plants have their dual purpose boiler. To produce power and run it. I don't know much beyond that.
Nick, I'm not the proper person to answer this question.
Okay, Nick, you go to next.
Yeah, I'm going to the next. Availability of indigenous detectors and sensors is mostly import oriented. Yes, that is very, very true, and has been perpetual problem of India. It is very, very true. But I'm telling you that many research institutes and many companies, they are trying to develop indigenous detectors and sensors, including our institute. Although we are not developing conventional sensors, but in the biosensor domain, we are trying to develop various biosensors. For various applications. In the health domain also, we are developing biosensors.
Very good.
Which type of servo motor, like step up, step down, this I'm not going into, I'm not answering this. Is there any AI system introduced in cross-country underground pipeline for transporting petroleum product to indicate? I'm not aware of this.
Okay.
Dr. Bhattacharya, are you aware of this? Is there any AI system introduced in cross-country underground pipeline for transporting petroleum product to indicate the health of pipelines, especially corrosion level? To indicate the theft of petroleum product, including leakage.
I don't know. Normally, I know that
There
they
are
use
some
SCADA
proprietary
system.
products. Some
Yeah.
proprietary products are there,
Okay.
which comes along with the instruments and equipments in that.
Okay.
But indigenous products probably not there.
Okay.
Next question is some queries. What is the tentative cost of the machine at present? And what is the gross weight of the unit, including battery? The gross weight of the unit, including battery, is around 400 kilogram. And cost, it is the developmental cost. So we haven't worked out the
So I'll
production
tell you
cost.
the cost will be around 5 lakhs. Cost will be around 5 lakhs for the machine.
That is production cost.
Yes, yes.
What is the operating time of the unit when the battery is fully charged, and what is the charging schedule? Presently the battery we are using, it can work in one go 4 to 5 hours in the field, and charging duration is around 8 to 10 hours.
Okay.
Thank you very much for accepting.
Go to next one.
With the advancement of technology and developing automation, how do you think future cities will evolve, or even our workplaces and homes? Like now we are hearing about virtual reality and metaverse advancement. I request Dr. Bhattacharya to answer this. With the advancement of technology and developing automation, how do you think future cities will evolve, or even our workplaces and homes?
There are some noise. Somebody has to mute.
Yeah.
The question is, shall I repeat the question?
Yeah.
With the advancement of technology and developing automation, how do you think future cities will evolve, or even our workplace and homes?
The smart city concept.
So I think this has been replied in the last few slides in your presentation, where there is going to be convergence of IoT and AI. That is for the first place. And this will produce new solutions for smarter operations at every walk of our life. That's also very sure. And that we must carefully harmonize and plan solutions towards Society 5.0 so that happiness is ensured for the members, for the people. So there will be automated solutions, there will be smart solutions, there will be exchange of informations with everything. Internet of everything is going to be.
Even now, people are talking about.
Controllability will be in hands. Yeah.
Even now, people are talking about IOH, Internet of Humans. So,
see, not only Internet of Human, there is a concept of Internet of Behavior. So that way, these are all various jugglery with the words, but the theme remains same. It is convergence of IoT, IoT and AI. And IoT, a number of IoTs, all pervading with harmonized AI, is going to lead us towards Society 5.0, as already highlighted by you in your presentation.
Next question is, lameness sensing is not clear. Lameness sensing means how much time the cow is active and how much time it is sitting idle or it is lying down. That gives clear indication about the health of the cow. Okay. Next question is, due to increasing trend in utilization of IoT and AI technologies, how it will affect the employment index of our country? Yes, employment, some of us may lose our jobs, but there will be new opportunities as in case of any new technology. When any new technology comes, there will be new services, new job opportunities. So ultimately, we'll get our jobs. In Seedec helping us Indian on library of IoT devices approvals. I don't understand this. Specs,
I think
performance,
CDM don't give a approval directly, I believe.
Yes.
The approval
Japanese
authority
are
is
planning
different.
for customization rather than mass production. This will help us to customize the varieties of crops by changing the environmental conditions. True. What is AI? Why AI is very much important to us? What is actuators? Actuators are devices, sensors. What sensors does? It senses the some parameters, physical parameters like temperature and humidity or any other parameter, process parameter or natural parameter. Now, what actuator actually does? Suppose temperature is too high, you need to close the valve so that temperature gets down. So this kind of work is done by actuators. These are electromechanical devices basically. Lameness sensing is not clear, already elaborated. 5G will introduce in the future cities very shortly. Already you might have got the news that some aeroplane companies, air companies, they are not they have stopped their services in US because 5G is already in trial in different US cities. So they have stopped their services. They are afraid that because of this trial, their security system may hamper. So it will going to be launched very soon. I mean, in 1-2 years in India. How IT will become developed.
Mr. Ghosh, thank you very much for the question answer session. May I now, we are already past time. May I request now Professor Nitosh Kumar Brahma, Honorary Secretary, West Bengal State Center, to propose vote of thanks.
Yeah, thank you. Am I?
Yeah, we can hear you.
Am I audible? Am I audible?
Yes, sir.
Yeah. So it is a gigantic lecture. So it is my first time that I've heard so gigantic, so complex natures of the lecture with IoT and AI. Well, your lecture, the last slide, with the revolutions of so-called industrial revolution of 4.0, and you have given the 5.0 as the human relation along with the biological development. I believe that will be the last consequence of our civilization. That will be the enormous challenge in our society. If you think in that way, with the time frame and the population growth, your technology will take some time, but at the same time, we are coming at the end of our civilizations of so-called in 2030, 9.5 billion global population, near about. The 6.5 billion, the developing country will suffer from the pressures of 3.0 billion populations of the developed nations. They have conquered the two things. One thing is the time, and the second thing is the energy. And we are fighting for that time and energy so very much. Anyhow, with that short introduction, I like to read what I have thought in the support of my colleagues. Just short the preamble. The artificial intelligence enables machine to behave like humans through learning, recognizing patterns, decision making, and solving problems. It makes decision by processing a large amount of complex, organized, and unorganized data obtained through a network of technologies and sensors, popularly known as the Internet of Things, IoT. IoT helps in the communication and interactions of the data without human interference. IoT produces a vast amount of data due to the rapid growth of smart devices, ranging from smartphones, computers, medical equipment, industrial meters, autonomous vehicles, etc. These data are analyzed in the real time by employing various AI models to predict the weather, climates, diseases, accidents, and many more. This is fact. The analysis results are utilized by human things in various forms for a better economy and better societies. Correct. This lecture focuses on the appropriate of AI, IoT, and robotics for overall growth and development, especially in the Indian agriculture domains. It is absolutely correct and matched with the lecture that Dr. Bhattacharya presently given us and highlighted. Happy New Year, and we believe that we are approaching the technology to solve our population growth and the demand of the population. The majority is the water, health, and medicine. It is really a great challenge with Indian scenario, and presently we have seen in the pandemics. It is my proud privilege to extend my sincere thanks and gratitude to all the distinguished participants in the technical webinar on the theme Convergence of IoT and AI, organized by the Electronics and Telecommunication Engineering Division of West Bengal State Center, IEI, through online platform Zoom. At the outset, I convey my sincere thanks to the panelists, Dr. Nabarun Bhattacharya, Senior Director and Center Head, Seedec, Calcutta, and Mr. Alokesh Ghosh, Associate Director, Seedec, on today's technical webinar, who have very nicely deliberated the lecture. And that's I already mentioned before I started to give the vote of thanks. My sincere thanks also goes to my colleague, Mr. Sandeep Kumar Dev, Chairman. I have seen him, but I was not able to come to the contact due to the net failure or something. IEI and our beloved President, IEI, Dr. H. Thakare. My heartfelt thanks also goes to Sri Ramchandra Chakravarti. It's a really brilliant in one sense that I've seen the only one division who actually arranged a fantastic lecture last 6 months that I have conducted. Engineering Division Subcommittee, etc., moderator of today's program. I convey my sincere thanks to all members of the Council, Division Board, members of the ETDB, Electronics Telecom Division Board, all members of the Committee of West Bengal State Center, IEI, all members of ET Engineering Division Subcommittee, West Bengal State Center, IEI, Director Technical, and his team of IEI for their wholehearted support to make the program a grand success. Last but not the least, my heartfelt thanks goes to all who are behind the screen to make this today's technical webinar a success. Thank you once again, and Happy New Year to follow with IoT and AI for the future. Okay,
thank you. Professor Brahmo. And thank from my side to all the participants for the encouraging participation. And we feel encouraged. Our next webinar will be on 24th February.
Yeah, my webinar will be in the 1st February.
Yes, I have seen, sir. Will come.
Please.
Thank you, Mr. President, Dr. Thakre, for your presence on screen for the entire more than 2 hours. Thank you very much for your encouraging presence, and look forward to have you in our successive webinars as well.
Thank you. Good night.
Thank you.
Thank you, sir. Thank you. Good night.
Everybody. Bye.
Thank you, sir.
Bye.
Bye, sir.
Namaskar.
Sir, you can end it, sir. You can end the webinar from your end, sir.
Okay. Thank you, Sudeep. Okay, with the kind permission of everybody, I just close the session.
Yes, I am also closing.